The surface of our planet is a world dictated by the sun. It is a realm of relentless motion, governed by the chaotic breath of the wind, the rhythmic pull of the moon, and the blinding, life-giving light that washes over the continents. We live our lives in this bright, noisy, and fast-paced environment, rarely pausing to consider the sheer volume of the world that exists beneath the waves. But to truly understand the Earth, we must leave the light behind. We must surrender to the quiet and begin a descent into the largest, least understood, and most mysterious habitat in the solar system. Imagine yourself slipping beneath the surface of the Pacific Ocean. Instantly, the roaring of the wind and the crashing of the waves are muffled, replaced by a profound, enveloping hush. The water around you is a vibrant, translucent blue, teeming with microscopic plankton, and the darting silver flashes of schooling fish. But as you sink deeper, the energy of the surface begins to fade. Gravity pulls you gently but inexorably downward. At 200 meters, the red spectrum of sunlight is entirely absorbed by the water. If you were to cut your hand, the blood would appear a deep, ink-like black. The vibrant colors of the coral reefs give way to a muted palette of blues and grays. This is the twilight zone, a place of shadows and shifting silhouettes where the last fading rays of the sun struggle to penetrate the increasing density of the ocean. As the descent continues past 1,000 meters, the ocean undergoes a fundamental transformation. The twilight is extinguished, swallowed completely by the midnight zone. Here, the darkness is absolute, unbroken, and eternal. It is a darkness that has existed since the oceans first formed on the cooling crust of the early Earth. The temperature plummets, hovering just a few fractions of a degree above freezing. The water feels heavy, thick, and utterly motionless. You are now falling through a void so vast it defies human imagination. A suspended inner space where day and night have absolutely no meaning. Yet even this oppressive, freezing darkness is not the bottom. To reach the deepest place on the planet, we must descend past the abyssal plains, dropping through the water column for hours until the ocean floor suddenly falls away into a colossal crescent-shaped scar. This is the Mariana Trench, an underwater canyon system stretching across the western Pacific for over 2,500 kilometers. It is a geological wound so massive that if you were to drop Mount Everest into its deepest point, the Challenger Deep, the peak of the mountain would still be submerged under more than 2 kilometers of crushing, freezing water. The scale of the Mariana Trench is terrifying, but it is the physical reality of the environment that truly boggles the mind. At a depth of nearly 11,000 meters, the concept of hydrostatic pressure ceases to be a mathematical equation and becomes a crushing, omnipresent physical force. The weight of the water column above presses down with a localized pressure of over 1,000 times the standard atmospheric pressure at sea level. Imagine the entire weight of a fully grown commercial airliner balanced on a single square inch of metal. It is the force exerted on every surface, every molecule, every living cell that dares to exist at the bottom of the world. Under this immense weight, water itself is compressed, its density fundamentally altered. It is an environment so hostile, so utterly alien to our surface-dwelling biology, that for centuries scientists believed it to be a dead zone, an empty basement of the Earth where life was physically impossible. But the ocean is a master of adaptation, and the dark is an incredible teacher. As we sink into the Challenger Deep, the silence becomes heavy and hypnotic. We are entering a world preserved in deep time, an isolated laboratory of extreme physics and slow-motion geology. The rushing of the modern world above is gone, replaced by the quiet, measured breathing of the deep Earth. Here, in the absolute black, the mysteries of planetary creation and the limits of biological endurance wait patiently to be discovered. The architecture of the Vide, the architecture of the Veen. The earth beneath our feet feels solid, permanent, and unchanging. But this is an illusion born of our fleeting human lifespans. On a geological time scale, the crest of our planet is a restless, shifting jigsaw puzzle of massive tectonic plates, forever grinding against one another, driven by the intense, churning heat of the mantle below. To understand the Mariana Trench, we must first understand the slow-motion violence. The trench is not merely a crack in the ocean floor. It is a battleground of continental proportions. It marks the precise, catastrophic boundary where two of these colossal plates collide. To the east lies the vast, heavy, and ancient Pacific Plate, a slab of basaltic rock that has been creeping westward across the globe for hundreds of millions of years. To the west lies the smaller, younger, and comparatively lighter Mariana Plate. When these two immense masses of rock meet, they do not simply buckle upward to form mountains as they do on land. Instead, because the oceanic crust of the Pacific Plate is older, colder, and denser, it is forced to yield. It is pushed downward, diving violently beneath the Mariana Plate in a geological process known as subduction. The subduction zone is the engine that excavates the abyss. As the Pacific Plate is dragged down into the superheated mantle of the Earth, it bends, tearing a massive V-shaped depression into the seafloor. Imagine pulling the edge of a heavy blanket down over the side of a bed. The deep crease that forms where the fabric bends is exactly how the trench is shaped. The forces at work here are almost beyond calculation. The friction generated by billions of tons of rock grinding past each other is unimaginable. This friction acts as a colossal planetary brake, causing the Pacific Plate to descend in a series of jagged, violent jerks. Each sudden movement releases a massive burst of seismic energy, triggering deep-sea earthquakes that reverberate through the water column and occasionally spawn devastating tsunamis on the surface. Yet down in the trench itself, these cataclysmic events are muffled by the immense pressure experienced only as a deep, resonant shudder running through the bedrock. As the descending plate plunges deeper into the mantle, the extreme heat and pressure cause the rock to melt, creating reservoirs of volatile magma. This magma eventually forces its way upward, punching through the overriding Mariana Plate to form a crescent-shaped arc of volcanic islands, the physical mirror image of the trench hidden below the waves. The physical architecture of the Mariana Trench is drastically different from the popular imagination of a narrow, sheer-walled chasm. It is not a vertical drop. Instead, the trench is incredibly wide, spanning roughly 69 kilometers across on average. The descent down its flanks is a gradual, treacherous slope, completely devoid of the smooth, sandy expanses that characterize shallower coastal waters. The walls of the abyss are composed of ancient oceanic basalt, jagged volcanic rock, and millions of years of accumulated marine sediment. It is a landscape of profound instability. Because the slopes are incredibly steep and the area is highly prone to seismic tremors, the trench walls are constantly collapsing. Massive underwater landslides, hundreds of times larger than any avalanche on land, occur with startling regularity. Millions of tons of mud, clay, and pulverized stone cascade silently into the depths, scouring the bedrock clean and burying everything in their path. These slow-motion avalanches reshape the topography of the Hadal Zone in an instant, creating deep ravines and vast, desolate fields of jagged rubble at the bottom. Resting at the very bottom of this subduction zone, in places like the Serena Deep and the Challenger Deep, the terrain flattens out into small, isolated basins. These basins act as the ultimate sinkholes for the entire Pacific Ocean. Everything that falls into the trench, whether it is the collapsing rock of a landslide, the decaying organic matter from the surface, or the fine, microscopic dust blown off the continents, eventually settles here. Over millions of years, this continuous rain of debris has carpeted the trench floor in a thick layer of fine yellowish-brown ooze. This sediment is incredibly soft, possessing the consistency of powdered sugar mixed with water. Any disturbance, such as the touchdown of a deep-sea submersible, instantly whips this ooze into a dense, milky cloud that can take hours to settle in the completely current-free, stagnant waters of the extreme deep. This environment is defined by its age and its isolation. The water at the bottom of the Mariana Trench is believed to be some of the oldest, most slowly circulating water on the planet. It is separated from the surface by miles of crushing pressure and distinct thermal boundaries that prevent mixing. The temperature down here sits at a constant, bone-chilling 1 to 4 degrees Celsius. It is a world locked in a state of perpetual freezing stasis. The architecture of the void is a testament to the raw, unfeeling power of planetary mechanics. It is a landscape utterly devoid of sunlight, sculpted by tectonic collisions, scarred by underwater avalanches, and buried beneath millions of years of silent, settling dust. It is a place that feels deeply, fundamentally alien, yet it is intimately connected to the very core of our world. As we float weightless in the pitch-black water, mere inches above the ancient, undisturbed sediment of the Challenger Deep, the true scale of the Earth's inner architecture becomes clear. We are not just exploring the bottom of the ocean, we are hovering over the very machinery that creates and destroys the continents above, the midnight sky. To understand the deepest realm of the ocean is to confront a physical force that surface-dwelling creatures can scarcely comprehend. Above the water, we move freely through an atmosphere of air, accustomed to a baseline pressure that gently holds our world together. We do not feel the weight of the miles of sky stacked above our heads. But water is a vastly different medium. It is heavy, dense, and relentlessly unforgiving. For every 10 meters you sink beneath the waves, the weight of the water above adds another full atmosphere of pressure. By the time you slip past the sunlit epipelagic zone and enter the dim twilight of the mesopelagic, the pressure has already reached levels capable of crushing a standard scuba cylinder. Yet, this is merely the shallow entryway to the true abyss. As the descent continues into the blackness of the bathypelagic zone, the weight multiplies with frightening mathematical precision. At 4,000 meters, the depth of the Titanic wreck, the pressure is roughly 400 times greater than at the surface. Steel begins to groan, and hollow spaces become catastrophic liabilities. But the Mariana Trench demands a journey far deeper than the resting places of sunken ocean liners. To reach the Hadal zone, the water column stretches down for another grueling 7 kilometers. At the very floor of the Challenger Deep, resting at 10,984 meters below sea level, the concept of hydrostatic pressure transforms into a monstrous, omnipresent physical wall. Here, the ocean presses in from all directions with a force exceeding 1,086 atmospheres. This translates to roughly 16,000 pounds of force bearing down on every single square inch of surface area. To visualize this invisible terror, one must imagine the entire mass of a fully grown African elephant balanced perfectly on an area no larger than a postage stamp, or 50 jumbo jets stacked upon the roof of a small car. It is a squeezing, crushing embrace that never yields, never softens, and never sleeps. Under this staggering load, the very physics of water begin to behave strangely. While scientists typically consider water to be an incompressible fluid, the sheer violence of the weight at the bottom of the trench forces the water molecules closer together. The water in the Hadal zone is noticeably denser and heavier than the water at the surface. In fact, if the ocean were truly incompressible from top to bottom, the sheer volume of the sea would expand, and global sea levels would sit roughly 30 meters higher than they do today. The weight of the deep ocean is literally pulling the surface of the planet downward. The extreme pressure of the Mariana Trench fundamentally alters the chemistry of the environment, creating a toxic barrier that strictly dictates what can and cannot exist in the dark. At the surface, countless marine organisms rely on calcium carbonate to build their shells, skeletons, and protective armors. From the massive coral reefs to the microscopic plankton that drift in the currents, calcium is the building block of oceanic architecture. But as pressure increases and temperature drops, the chemical rules change. Deep in the water column lies a boundary known as the calcium carbonate compensation depth. Below this invisible line, the crushing pressure causes the water to become highly corrosive to calcium. Any shell or bone that drifts down from the surface begins to dissolve, melting away into the surrounding water long before it ever reaches the trench floor. This is why the bottom of the abyss is not littered with the gleaming white skeletons of whales or the shells of ancient mollusks. The pressure literally erodes the architecture of life, stripping away the familiar forms of biology and leaving only the most specialized pressure-resistant materials behind. Anything relying on a hollow cavity or a rigid, calcium-based frame is destined to be crushed or dissolved in the freezing depths. For humanity, surviving this environment requires engineering miracles that push the absolute limits of material science. A modern military submarine, forged from thick plates of high-yield steel and titanium, is a marvel of resilience, yet it would suffer a violent, instantaneous implosion if it attempted to dive even a fraction of the way into the trench. The metal hull would buckle and fold inward at a speed faster than the human brain can process pain, creating a shockwave of immense heat as the surrounding water rushed in to fill the void. To touch the bottom of the Mariana Trench, engineers must rely on perfect geometry. The only shape capable of withstanding the uniform crushing force of 1,000 atmospheres is a perfect sphere. Milled from solid blocks of specialized titanium alloys, the crew compartments of deep-sea submersibles are incredibly cramped, offering barely enough room for a pilot to bend their knees. The walls of these spheres must be several inches thick, machined to microscopic tolerances, because even the slightest imperfection, a scratch or minute internal bubble in the metal, could become a focal point for the pressure, leading to catastrophic failure. The acrylic viewports, the only connection between the fragile humans inside and the crushing dark outside, must be conical, shaped like massive corks that the ocean's weight pushes deeper into their titanium seats, creating a seal that only grows stronger as the depth increases. Yet perhaps the most profound effect of this unimaginable pressure is the overwhelming, hypnotic stillness it creates. The deeper you go, the thicker and more unyielding the water becomes. It dampens movement, slows the drift to falling sediment, and holds the environment in a state of suspended animation. The crushing weight suffocates the violent currents that tear across the upper layers of the ocean. In the deepest basins of the trench, the water is virtually stagnant, moving at a glacial pace. This lack of disturbance means that the fine, silty mud of the seabed has sat in utter silence for millions of years. A single disturbance, the gentle touchdown of a submersible's landing skid, can whip up a cloud of pale dust that will hang suspended in the heavy water for hours or even days, refusing to settle. It is an environment locked in a terrifying, beautiful equilibrium. The weight of the midnight sky presses down, flattening time, dissolving bone, and demanding absolute perfection from anything that dares to enter its domain. As we hover in the pitch-black water, enclosed in our imaginary sphere of titanium, the silence is so heavy it feels tangible. We are completely isolated from the sunlit world above, swallowed by a crushing void that should, by all logic, be entirely devoid of life. And yet, as the lights of our vessel cut through the eternal night, illuminating the barren, pale mud of the abyss, we begin to realize that the dark is not empty at all. The pressure has not eliminated life. It has simply forged it into shapes we are only just beginning to understand. Breaking the eternal seal. For the vast majority of human history, the ocean was understood strictly as a two-dimensional plane. We mapped the jagged coastlines, navigated the surface currents, and sailed toward distant, flat horizons, completely blind to the unimaginable volume of the world that existed beneath the waves. The vertical dimension of our planet was a terrifying, inaccessible void. Ancient mariners harbored dark superstitions about the deep, believing that the ocean possessed no true bottom, or that the crushing depths were a suspended purgatory, where sinking ships and the souls of the drowned would float in perpetual, agonizing twilight. Even as modern science began to map the seafloor using acoustic sonar, revealing the colossal trenches and towering underwater mountain ranges, the abyss remained a physical impossibility. To reach the Hadal Zone, humanity needed to overcome a barrier far more formidable than the vacuum of space. While a spacecraft must be designed to contain exactly 1 atmosphere of pressure against the empty vacuum outside, a vessel destined for the Mariana Trench must be engineered to hold back 1,000 atmospheres of crushing, relentless weight from the outside in. Standard submarines, reliant on hollow air tanks to control their buoyancy, were completely useless. At a depth of 10,000 meters, the ambient pressure compresses air until it becomes as dense as the water itself, stripping it of all lifting power and instantly crumpling any standard metal hull. Reaching the bottom of the Earth required a radical departure from everything engineers thought they knew about maritime architecture. It required a machine built not to fight the pressure, but to cheat it. The answer came in the form of a bizarre, unprecedented vessel called a bathyscaphe, a name derived from the Greek words for deep and ship. Invented by the eccentric and brilliant Swiss physicist Auguste Piccard, the bathyscaphe operated on the same fundamental principles as a hot air balloon, but inverted to conquer the deep ocean. Rather than using a massive envelope filled with hot, buoyant air to lift a basket into the sky, Picard designed a colossal cylindrical float nearly 60 feet long to drag a tiny cabin down into the abyss. But this float could not be filled with air, or the ocean would crush it instantly. Instead, it was filled with over 32,000 gallons of highly refined aviation gasoline. Because gasoline is significantly lighter than seawater, it provided massive upward buoyancy. Crucially, gasoline is also a liquid, and therefore virtually incompressible. As the vessel descended into the crushing depths, the gasoline inside the float would not compress, allowing the thin metal skin of the massive cylinder to maintain its shape without imploding. Suspended securely beneath this gargantuan, highly flammable reservoir was the true marvel of the bathyscaphe, the pressure sphere. Forged by the Krupp Steelworks in Germany from ultra-high-yield steel alloys, the sphere was incredibly small, measuring just over 2 meters in diameter, with walls roughly 13 centimeters thick. It was a heavy, cramped, and entirely unpowered metal womb, equipped with only a few banks of silver-zinc batteries at a single cone-shaped acrylic viewport. To drag this buoyant monstrosity down to the trench, the vessel carried 9 tons of iron pellets, held securely in place by powerful electromagnets. To ascend, the crew simply had to cut the electrical power. The magnets would release the heavy iron into the mud, and the buoyant gasoline would pull them safely back to the sunlit world above. They named this strange revolutionary machine the Trieste. On the morning of January 23, 1960, the Pacific Ocean above the Challenger Deep was a canvas of hostility. The sea was churned by high winds, sending towering gray swells crashing against the hull of the support ships. Inside the cramped, freezing steel sphere of the Trieste, 2 men prepared to leave the known world behind. Jacques Picard, the son of the vessel's inventor, and United States Navy Lieutenant Don Walsh, squeezed themselves into the tiny cabin, surrounded by a labyrinth of dials, gauges, and rudimentary electronic wiring. Above them, the massive steel hatch, weighing hundreds of pounds, was forcefully bolted shut from the outside, locking them into a pressurized tomb. They were completely severed from the elements, breathing purified oxygen and relying entirely on the integrity of their steel sanctuary. With a final check of the instruments, the signal was given. The Trieste flooded its water ballast tanks, slipping beneath the violent surface waves, and the slow, agonizing descent began. It was not a dive in the traditional sense. It was a controlled, hypnotic fall through an endless column of water. As they slipped past the first 100 meters, the violent motion of the surface storms vanished entirely, replaced by a profound, heavy stillness. The vibrant blue of the Pacific rapidly faded, bruising into a deep, melancholic purple, before finally surrendering to the absolute, suffocating blackness of the bathypelagic zone. The fall was an exercise in extreme psychological endurance. Inside the uninsulated steel sphere, the temperature plummeted in tandem with the surrounding water, hovering just above freezing. The moisture from their breath rapidly condensed on the icy metal walls, dripping continuously down onto the floor. For hours, they sat in shivering silence, watching the depth gauge spin relentlessly deeper. 3,000 meters, 5,000 meters, 7,000 meters. 7,000 meters. They passed the depth of the ocean's abyssal plains, entering the true Hadal Zone, a realm where no human being had ever ventured. The darkness outside their tiny viewport was absolute, broken only occasionally by the ghostly, bioluminescent flashes of deep-sea jellyfish and comb jellies colliding with the hull-brief sparks of cold alien fire in the eternal night. As the pressure mounted to unimaginable levels, the Trieste began to speak to them. The intense squeezing force caused the various components of the massive float above them to shift and compress. The silence of the cabin was frequently punctuated by loud metallic groans, sharp snaps, and the terrifying sound of shrinking metal echoing through the water. They were falling into a physical environment that desperately wanted to crush them, sustained only by the microscopic tolerances of German steel engineering. At a depth of nearly 30,000 feet, roughly 9 kilometers beneath the surface, the creeping tension inside the cabin was shattered by a sudden, violent catastrophe. A sharp, deafening crack, sounding exactly like a large-caliber gunshot, reverberated violently through the tiny sphere, shaking the entire vessel. The ocean was testing the structural limits of their survival. The immense hydrostatic pressure, squeezing the sphere from every conceivable angle, had caused one of the outer acrylic window panes in the entry tunnel to buckle and fracture under the strain. In an instant, Picard and Walsh faced the very real, immediate possibility of total annihilation. At a pressure of over 900 atmospheres, a structural failure would not result in a slow leak or a dramatic drowning. The immense weight of the ocean would force the water into the cabin so violently that the trapped air inside would instantly superheat, vaporizing both men in a fraction of a second before the metal itself crumpled into a tight, unrecognizable ball. The two explorers sat frozen, their eyes locked on the dripping walls, waiting for the fatal rush of water. But the primary pressure hull held fast. The thick steel, designed with massive safety margins, refused to yield to the abyss. In a display of profound courage, and perhaps a touch of calculated madness, they assessed the situation and made the quiet decision to keep the electromagnets engaged. They chose to continue the descent, plunging deeper into the danger. Finally, after nearly 5 hours of continuous nerve-wracking freefall, the faint ping of the downward-facing fathometer indicated that the bottom was rushing up to meet them. Picard carefully cut the power to a portion of the electromagnets, releasing a shower of iron pellets to slow their momentum, aiming for a feather-light touchdown on the floor of the trench. But as the heavy steel sphere gently kissed the bottom of the Challenger deep, it disturbed an environment that had sat in absolute motionless silence for millions of years. The impact instantly whipped up a massive, billowing cloud of fine, pale sediment. It was a localized avalanche of accumulated abyssal dust, a milky blizzard that completely swallowed the Trieste. When they turned on their exterior mercury vapor lamps, the harsh white light penetrated only a few inches into the swirling vortex of mud. They were completely blind, sitting at the lowest physical point on the surface of the Earth, buried in the ancient silt of the deep. The depth gauge read an astonishing 10,916 meters. They had broken the ultimate boundary, reaching a place that was, by all accounts, further away from human civilization than the surface of the moon. They remained on the bottom of the world for a mere 20 minutes. The cold was seeping deeply into their bones, and the fractured window pane in the antechamber remained a constant, terrifying threat. Yet in those fleeting minutes, just before the pale sediment completely obscured their tiny viewport, they witnessed something that would permanently alter the course of biological science. Illuminating the seabed with their exterior lights, both Picard and Walsh reported seeing a shape moving sluggishly on the pale mud. It was a flatfish, resembling a common sole or a flounder, roughly a foot in length, with 2 prominent eyes situated on the top of its head. It slowly undulated its pale, flat body and swam lazily away, disappearing into the swirling cloud of dust. While modern marine biologists debate the exact species of the creature, suggesting it may have been a highly specialized sea cucumber rather than a true bony fish, the taxonomic classification is entirely secondary to the monumental implication of the sighting. That single fleeting glimpse proved without a shadow of a doubt that complex, active, macroscopic life existed at the absolute bottom of the ocean. It survived and even thrived under a pressure that crushed high-yield steel and in a darkness that had never known the warmth of a single photon from the sun. The abyss was not a dead, barren wasteland. It was a living, breathing ecosystem. With their time exhausted and the chill becoming unbearable, Picard reached out and permanently severed the power to the electromagnets. The remaining tons of iron ballast rained down into the Hadal mud, and the Trieste, suddenly far lighter than the immense volume of water displaced by its massive gasoline float, shuddered and began its slow, relentless journey upward. They left the bottom of the trench behind, ascending back through the layers of crushing darkness, rising toward the distant promise of light and air. When they finally broke the surface of the Pacific, bobbing violently in the rough swells, they had accomplished a feat of exploration unparalleled in human history. It had opened the door to the deepest frontier on the planet. Yet incredibly, the door they forced open would immediately slam shut behind them. The sheer expense, the terrifying danger, and the immense technological difficulty of operating a bathyscaphe meant that after the Trieste was eventually retired and towed away to a museum, no human being would return to the bottom of the Mariana Trench. The deepest place on Earth was plunged immediately back into its eternal, undisturbed isolation, its secrets once again guarded by miles of freezing water, leaving humanity to wonder what else might be waiting in the darkness just beyond the edge of that single fractured beam of light. The ghostly harvest of the abyss on the surface of our planet, the relentless machinery of life, is fueled entirely by a single blazing star. The sun bathes the upper layers of the ocean in radiant energy, allowing microscopic phytoplankton to perform the miraculous alchemy of photosynthesis. They weave sunlight, water, and carbon dioxide into the organic sugars that form the foundational base of the entire global food web. Every shimmering school of mackerel, every apex predator patrolling the reefs, and every massive baleen whale migrating across the hemispheres ultimately owes its existence to this solar harvest. But as we fall deeper into the Mariana Trench, passing beyond the absolute limits of light penetration, this fundamental rule of biology is violently broken. At a depth of 10,000 meters, the energy economy of the ocean collapses entirely. There are no plants, no algae, and no primary producers to anchor the ecosystem. To a biologist trained only in the sunlit shallows, the Hadal Zone appears to be a nutritional void, a freezing, crushing desert incapable of supporting anything more complex than dormant bacteria. Yet, as the pioneering descent of the Trieste proved, life does not simply surrender to the dark. It adapts with terrifying efficiency. To survive in the Mariana Trench, the creatures of the deep have been forced to abandon the sun and rely instead on a slow, continuous, and hauntingly beautiful phenomenon known as marine snow. If you were to suspend a submersible halfway down the water column, turning its harsh halogen lights outward into the blackness, you would not see a pristine, empty void. You would see a blizzard. The water is filled with a constant, drifting shower of pale particulate matter falling silently from the world above. This is marine snow, the primary currency of life in the deep ocean. It is a macabre confetti composed of the decaying detritus of the surface world, the microscopic corpses of single-celled diatoms, the discarded gelatinous shells of pelagic tunicates, the fecal pellets of millions of schooling fish, and the drifting soot of atmospheric dust, held together by sticky, translucent webs of bacterial mucus. These flakes of organic matter clump together, growing heavier as they slowly sink. It is a mesmerizing, slow-motion rainfall of death that sustains everything living in the eternal night. But the journey from the sunlit epipelagic zone to the bottom of the Mariana Trench is an agonizingly slow and perilous gauntlet. Because the water in the deep ocean is incredibly cold and thick, a single flake of marine snow may take weeks or even months to fall the full 11 kilometers to the Challenger Deep. Throughout this long descent, the snow is relentlessly hunted. As it drifts through the twilight and midnight zones, it is intercepted, consumed, digested, and excreted repeatedly by thousands of species of midwater organisms. Vampire squids deploy long, sticky filaments to capture the falling debris, while massive schools of lanternfish rise and fall with the setting sun to graze on the descending bounty. By the time this organic rain finally crosses the threshold of the Hadal Zone and settles onto the soft, pale mud of the trench floor, its nutritional value has been profoundly diminished. It is estimated that less than 1% of the organic matter produced at the surface ever reaches the absolute bottom of the ocean. The ecosystem of the Mariana Trench is therefore built upon a foundation of extreme, perpetual starvation. The animals that reside here are not the fast, muscular predators of the surface. They are absolute masters of energy conservation, possessing incredibly slow metabolisms that allow them to stretch a single meager meal over agonizingly long periods. They drift or scuttle across the seabed with a sluggish, hypnotic patience, their bodies chilled to just a few degrees above freezing, husbanding every fraction of a calorie. The most successful scavengers of this desolate plain are the amphipods. In shallow coastal waters, amphipods are tiny, harmless crustaceans, often resembling tiny jumping sand fleas no larger than a grain of rice. But in the crushing depths of the Mariana Trench, the rules of physical development are warped by a phenomenon known as abyssal gigantism. Here, a species known as Hirondellea gaius dominates the mud. These creatures resemble overgrown, pale pillbugs growing up to 30 centimeters in length. They are completely blind, their bodies devoid of any pigment, appearing as ghostly, semi-translucent shadows moving over the yellow sediment. Their survival in this environment is nothing short of a biochemical miracle. To prevent their fragile exoskeletons from dissolving in the highly pressurized calcium-starved water, these amphipods have developed a brilliant evolutionary hack. They extract trace amounts of aluminum ions from the surrounding seafloor mud and secrete it over their bodies, forging a microscopic metallic shield that protects their internal chemistry from the crushing weight of the ocean. Furthermore, their digestive tracts are equipped with specialized enzymes capable of breaking down the tough cellulose wood. When a waterlogged tree trunk, swept out to sea by a distant tropical typhoon, finally sinks into the trench, it becomes a multi-generational feast for these aluminum-armored scavengers. But occasionally the slow, meager drip of marine snow is violently interrupted by the arrival of a true bounty, an event that reshapes the local ecosystem for decades. This is the whale fall. When a massive cetacean, perhaps a 50-ton sperm whale or a blue whale, dies of old age or disease at the surface, its massive corpse eventually loses its buoyancy and begins a rapid, catastrophic plunge into the abyss. It impacts the soft sediment of the trench floor like a biological meteor, sending up a massive cloud of pale dust and creating an immediate, localized oasis in the nutritional desert. The scent of decaying flesh, carried on the faintest, imperceptible microcurrents of the deep, acts as a dinner bell for the huddle scavengers. Within hours, the carcass is swarmed. Pale, sightless sleeper sharks emerge from the gloom, taking massive, slow-motion bites from the blubber. Thousands of hagfish, primitive, jawless scavengers that look like thick, gray eels, burrow directly into the meat, absorbing nutrients through their skin and secreting massive volumes of suffocating slime to deter competitors. Millions of giant amphipods blanket the seabed, stripping the bones with terrifying efficiency. This frenzied scavenging stage can last for several years, slowly reducing the massive leviathan to a pristine white skeleton resting on the mud. But the feast does not end there. Once the flesh is gone, a new wave of highly specialized colonization begins. The bones of a whale are rich in lipids and heavy fats. From the darkness emerge microscopic spores that settle on the skeleton, blooming into fields of bizarre bone-eating worms known as ossidacs. Lacking a mouth or a stomach, these worms use acid-secreting roots to bore directly into the dense marrow of the whale bones, relying on symbiotic bacteria to digest the fats. They blanket the massive ribs in a thick, undulating carpet of red, feathery plumes, slowly dissolving the skeleton over a period of 50 to 100 years. The whale fall is a profound demonstration of the deep ocean's absolute reliance on the surface. Everything in the Mariana Trench, from the microscopic bacteria in the mud to the giant pale crustaceans, is tethered to the sunlit world above, feeding on its scraps, its cast-offs, and its dead. It is a shadowy, ghostly reflection of the life that dances in the light. But as the technology of deep-sea exploration advanced in the late 20th century, scientists probing these extreme depths would soon make a discovery that would shatter this long-held biological paradigm. They would find that in certain isolated pockets of the abyss, life does not wait patiently for food to fall from the sky. Somewhere in the crushing dark, the earth itself provides the fire necessary to fuel an entirely alien ecosystem. For decades, the fundamental law of terrestrial biology remained unchallenged. All complex ecosystems require the energy of the sun to survive. The deepest, darkest trenches of the ocean were viewed entirely as biological graveyards, sustained only by the slow, decaying rain of marine snow falling from the world above. But the Mariana Trench hides a secret that completely shattered this paradigm. Hidden deep within its volcanic folds along the jagged ridges where the tectonic plates grind together, the ocean floor cracks open. Seawater, under immense hydrostatic pressure, seeps down into these deep fissures, penetrating the Earth's crust until it encounters the superheated magma chambers bubbling just below the surface. The water is instantly superheated to temperatures exceeding 400 degrees Celsius. Yet, because the crushing weight of the water column above is so absolute, this liquid cannot physically turn into steam. Instead, it becomes a volatile, highly acidic fluid, dissolving massive amounts of heavy metals and toxic hydrogen sulfide from the surrounding rock. This superheated, chemical-rich cocktail is then violently expelled back up through the seabed, colliding with the near-freezing water of the Hadal Zone. As the extreme temperatures clash, the dissolved minerals instantly precipitate, building eerie, towering chimneys of dark stone known as black smokers. To any creature native to the sunlit world, these hydrothermal vents are toxic, boiling cauldrons of death, but in the pitch-black void of the abyss, they are thriving oases of life. Here, the energy does not come from the sun, but from the fiery heart of the earth itself. The foundation of this alien ecosystem is a microscopic miracle known as chemosynthesis. Specialized extremophile bacteria have evolved to consume the highly toxic hydrogen sulfide billowing from the vents, breaking down the chemical bonds to produce organic energy in the complete absence of light. These bacteria are the primary producers of the deep, the subterranean equivalent of plants. Around these smoking chimneys, life explodes in astonishing densities, creating isolated islands of biological intensity amidst the barren, pale mud. There are fields of giant tube worms, encased in thick, white chitinous tubes, their bright red, feathery plumes swaying gently in the heated currents. These worms have no mouth, no stomach, and no digestive tract. Instead, their bodies are entirely packed with billions of chemosynthetic bacteria in a perfect symbiotic relationship, feeding directly off the chemical fire. Moving silently among the tube worms are ghostly, pale crabs and squat lobsters, blind scavengers that graze on the thick mats of bacteria carpeting the rocks. Translucent, gelatinous fish dart through the shimmering, heated water, while highly specialized octopuses, completely devoid of pigment, crawl slowly over the jagged volcanic glass. This is an ecosystem completely detached from the surface of the planet. If the sun were to suddenly extinguish and the oceans above froze solid, the creatures gathered around these hydrothermal vents would never even notice. They would continue to thrive, fueled by the slow, radioactive decay of the planet's core. The discovery of these deep-sea vents did more than just rewrite the biology textbooks. It expanded our understanding of where life might exist in the universe. If complex ecosystems can flourish in the toxic, crushing, lightless depths of the Mariana Trench, relying solely on internal planetary heat, then similar habitats could exist right now beneath the miles of ice on Jupiter's moon Europa or Saturn's moon Enceladus. The abyss teaches us that life is not a fragile anomaly, but a relentless, unstoppable force that will adapt to the most extreme conditions imaginable. As we slowly release our iron ballast and begin the long, quiet ascent back toward the surface, the glowing chimneys of the deep fade back into the absolute darkness. The freezing, heavy water of the Hadal Zone envelops us once more. Leaving the Mariana Trench is like waking from a profound, heavy dream. The deep ocean is not the terrifying, empty monster of ancient myth. It is a place of hypnotic stillness, of slow-motion time, and of astonishing resilience. It is a vast, hidden library containing the secrets of our planet's fiery formation and the absolute limits of biological survival. We return to the bright, noisy world above, bringing with us the humbling realization of our own smallness. We live our lives entirely on the thin, sunlit skin of the planet, while beneath the waves, a massive, silent world continues its slow, ancient rhythms in the dark. There is still so much of our Earth left uncharted, waiting quietly in the shadows for those brave enough to dive into the deep. As we finally break the surface and return to the light, take a deep breath and let the quiet mysteries of the abyss wash over you. If this journey into the dark has brought you peace, and if you wish to continue exploring the hidden corners of our beautiful planet, please leave a like on this video. It helps our small expedition grow. To ensure you never miss our next descent into the unknown, gently click the subscribe button and turn on notifications. The world is full of untold stories and unseen wonders. Until our next expedition, close your eyes, drift with the current, and rest well.